Am I audible? Am I not? Hello. Hi guys. Good morning. Um, let's see who are here for sure. How many people of you actually did it? I mean, like after around 30 40 minute or maybe 50 minute, maybe one hour, not sure. That firstly, if the folks have joined in, can we please tell like who all are here? And for sure, if you were able to get it, if you were able to try the problems at least, if you were able to see the problems at least, then for sure please write down below. And yeah, let's quickly smash that like baby. Let's reach 10 likes and we'll quickly jump on problem statements. We will not jump more on what's happening, what's not. We had done it more a while. Ashutosh solve 1 2 3. Great Ashutosh, at least you are able to see the problems. Jay Kumar, hey, hi Jay. Let's quickly smash that like baby, at least 10 likes. You guys have 14. थोड़ा बनता है. Our standard Riti was first and second he solved हुए, no worries. Third was actually, if you had been following, it should have been easy, but still we'll actually see it. But quickly, the folks are joining in. Can we smash that like maybe 10 likes and quickly jump on the problem statement? It's very easy. First, second, third, fourth, all were easy. To be frank, very easy. It's just that Leetcode showed its color by not giving, like, it happens usually like in the middle of the contest. I was there doing nothing. Let's make a shot. Made that shot. And yeah, if the folks have not watched the community post, please go and watch that. And also latest shot on Leetcode server being down, that's also a nice thing. But cool, let's quickly go on the first problem. Longest alternating sub array, many ways to do it. Let's see the problem statement itself. It just says, okay, you are having a zero indexed integer array called as nums. A sub array s of length m is called alternating if, okay, it's alternating if we have something like S0, S1, S0, S1 and so on and so forth, then it is called an alternating sub array, right? Now we have to return the maximum length of all alternating sub array present in the nums, or -1 if there is no such a sub array which exists in nums. Now it just say, okay, what's a sub array like? So firstly, we can easily see that, okay, one alternating sub array, it can be 2, 3. It cannot go more beyond because it needs to be 2, 3, 2, 3 and so on and so forth, but it will just stuck here 2, 3. If I just start from 3, I can see 3, 4, 3, 4, it just goes on. Okay, this is, so I just want the maximum sub array size. One sub array I saw it was a 2, 3, size is 2. One sub array I saw it was a size of 4. So for sure the maximum sub array size is actually a 4. So the answer is 4. Now in this I see, okay, it is 4, 5. Now it needs to be 4, 5, 4, 5 and so on and so forth. It will not go beyond. Cool, no worries. From 5, if I just see, it will be 5, 6. It can't go beyond because it is ended. So 2 here and 2 here also. So maximum I can get is a 2. So by looking at the example itself, we can clearly see that one thing for sure is I start from my index. I try to stretch it down. I try to stretch that down and see, okay, until how far I can go. I started from this index. I am starting from 2. I will stretch it down 2 and then I will stretch it down 3. Okay, I can go. I just stretch more. It needs to come 2 again. It is coming? No, it is not. So for sure I can go up till here itself. So my answer is size 2. Now I will move on to the next index. Then again I am starting at 3. I will stretch it down. Okay, 4. Then again stretch it down. Okay, 3. Again stretch. Okay, 4. Again stretch. Okay, it's ended. Okay, the size is 4. So update the maximum size. So one way is to go via the question way, to get this sub array and check if that sub array is alternating or not. Or other ways, as we saw while looking at the example itself, start from an index and use a sliding window kind of approach to find, okay, what is the length of that maximum sub array. Constraints are pretty low, so we can actually go anyways, find all the subarrays which are n squared subarrays and then check for every subarray by taking other O of n time, extra O of n time, to see if that is alternating or not. or do a sliding window kind of approach, which means start from an index and then just slide down and see how far you can go by just using, okay, for every index you will just try to slide down as max as possible. Here I just slide, okay, 2 3, cool, no worries. Then from 3 I just slide down 3 4 3 4, okay, no worries. Then maybe from 4 I just slide again. So basically for every index I am sliding O of n times, so it can be O of n square itself. So anyways you can do either brute force or a bit optimization by sliding window kind of approach. Anyways it is working for you guys. So it just said, okay, what the question was saying, just implementing that same stuff in the answer. Anyway, brute force also would work for sure. Let's quickly jump on the coding itself, but before that, can we reach 20 likes? Just one more like, that would be super great, because we are actually going on pretty easy. Like we will not waste time much on the altu faltu stuff. We will actually simply go and where's my coding screen? Oh, I didn't open my coding screen. Let me switch to my coding screen as fast as possible. Yep, so it should be visible. Yep, so it was very simple, a simple brute force kind of stuff. See, it doesn't matter for this question, apply anything. The one you are saying, it's a O of n cube algorithm. Simply you can also use O of n square one. You can optimize that much more further if you want, but still it's not required. Simply I just got the answer, okay, it is -1 if it is not there. I just got all the sub arrays for like simply a loop I to n, and then from I plus 1 to n. So getting all these subarrays from I to j, and then I just check for that subarray from I to j if that is an alternating or not. So is alternating, will get, okay, if that is alternating from I to j or not. So if it is alternating, then I will update my answer with the maximum answer of answer comma j minus I plus 1, which is the length of that subarray. And this alternating function will just go and check from that index, which is A to actually B. It will go and check if that is alternating or not, simply getting that starting, and then it should go on repeating. Okay, if it is actually next element, so it should be st plus 1. If it is the next element, then it should be st, and thus going on st plus 1, st plus 1, st plus 1, like this and so on. It will just keep on going and keep on saying. If at any point my flag is true but my flag becomes a false, then I can simply go on and say, hey bro, please, the flag has become false. So it will simply return a 0, or else it will return a 1, which means saying that, okay, that was alternating. So that was it for the first problem. Anyways you can apply, you can also use that sliding window kind of approach, which I said, okay, you have the I pointer, then you can just go and try to move your j as far as possible. Then with that you will get to know, okay, your j, how far it can move. Cool. Let's quickly jump on the question number 2. It's also pretty easy, but before that, can we reach 30 likes? That would be great. This contest would be unrated, right? Yeah, it should be unrated. बात चालू हुआ, हाँ यार, मतलब मेरा तो 50 मिनट बाद हुआ या 1 घंटे बाद, मुझे ये भी याद नहीं है. प्रिंस कैसे हो भैया? बस प्रिंस जी आपकी दुआ से बढ़िया है. मीट left the contest because tired of server down again and again. It's just like we should not leave it. It's just a fun kind of, it happens, no worries. But yeah, after 50 minutes it came in back, so let's try and have it. Proper time nahi mila third ke liye, no worries. The contest should be unrated. I started at 50 minutes, that should be unrated, yeah, for sure. Let's code, all questions are easy, yeah, correct. Ashutosh Verma, I could not find why question 3 was not a DP and just simple recursion, because the constraints are pretty small. We will actually see why, but the constraints are pretty small. If you go and see, that is it is around 32k if you go in recursion ways for complexity wise. But since n was just up to 15, so I wrote the basic recursion code and got accepted. Cool. That is also great. Question 3 was partition DP just like palindrome partition, correct. Since sir C question ne rula diya aaj. See, recursion question should not make you cry for sure, because it's actually it was very intuitive that, okay, it's a recursion question, and then maybe if the complexity would have been high, we could have applied DP. Even if you applied DP or not, still it doesn't matter as such, because still it would have passed. So see, that's it. See, I just want you guys, especially my audience, I just want you guys to get very good at recursion. And that's the reason specifically, because if you get good at recursion, you will for sure good at DP. And DP and graph and binary search are the three things which are actually, it seems hard to the people. And the only reason is because they could not understand when to apply binary search is the reason they could not understand binary search. How to apply recursion, it's the reason they could not apply a DP, and how to think of graph, they could not apply a graph. So it's the reason specifically I focus a lot when I specifically teach any question of a DP, graph or binary search. So that's the main focus. So please go and watch the problem solving intuition playlist for DP, graph and binary search specifically to actually get good at these three. See word break जैसा लगा. Thanks भाई आज का contest explain करने के लिए. No worries Zeta. Cool. Let's quickly jump on to question number 2. But before that, can we just 30 likes? Just one more likes, that would be great. Relocate marbles. It's actually simple again. We are having a zero index integer array called as sums. Firstly, बहुत ठंड हो रही है, पता नहीं इतनी ठंड कैसे बढ़ गई, but yeah, it's super cold. I don't know. I didn't have clothes, so I'm wearing this. Cool. Side thing. But yeah, zero index integer array nums representing the initial positions of some marbles. So basically, we have some marbles and its initial positions is represented in the nums. Now, you're also given two index integers, move from to move to. Okay, I can move from, let's say it's an array. Okay, it's an array and it's another an array. We'll see with the example itself what it say, but yeah, I can move from to move to. Cool. Throughout move from length steps, you will change the positions of the marbles. On the ith step, you will move all the marbles at the position move from I to move to I. So basically, you can move all the marbles at the position move from I to the position move to I. And after completing all these steps, return the shortest list of occupied positions. Sorted list of occupied positions. What all? After moving some marbles at this position to this positions, what is ultimately the occupied positions, and return that in the sorted order. Cool. Like all the positions are called as occupied if at least one marble is at that place. Now let's see the example. It will be much more clear with this. So if we have this as 1, 6, let me have it here, 1, 6, 7 and 8. So basically one marble is at 1, one marble is at 6, one marble is at 7, one marble is at 8. Now I can move all the marbles at 1 to at location 2. So all the marbles, I have only one marble at location 1. So I will move this one marble at location 1 to location 2. Cool. Location 2 I have moved it. I will move all the marbles at location 7 to location 9. Cool. All the marbles, I have only one marble, so I will move that location 9. I will move all the marbles from location 2 to actually location 5. All the marbles at location 2, and I have only one marble, so I will move that location to location 5. Ultimately, I have this locations, but return that in the, and see, this means at every location, it means at this location one marble is placed, at this location one marble is placed, but I need to return that in the sorted order. So return 5, 6, 8 and 9, and that is the answer itself. Now this was actually good to understand it, but to actually start thinking how to think what's going to be applied, let's look at the next example. It will give you much more clearer picture of how to think of what's gonna be applied. Now I have 1, 1, 3, 3, which means one marble is placed at location 1. Okay, at location 1, one marble is placed. At location 1, another marble is placed. So at location 1, two marbles are placed now. Now at location 3, one marble is placed. At location 3, another marble is placed. Okay. Earlier you saw that at every location only one marble was placed, so it was no worries at all for us. But now we saw that okay, at location 1 two marbles are placed, at location 3 another two marbles are placed. So now I have to go and shift all the marbles at location 1 to all the marbles, like let's say at location 1 I have, let's say, X marbles. So, and I know okay, X marbles are now going to be placed on this location 2. So place these X marbles at location 2 and remove them from location 1. And that's the same thing which you have to do. I have these two marbles at location 1 and I have to shift them to what? to location 2. So what I will do is I will shift these marbles from 1 to location 2 and remove them. See what I did. It was at location 1. I removed that from location 1. From location 1, all the marbles are gone, and all of them have been shifted to location 2. Now as soon as the location 3 came in, I know all the marbles at location 3. Let's say I have X marbles at location 3, and to shift all these X marbles to actually location 2. So I will shift these X marbles at location 2. Cool. X marbles, whatsoever marbles at location 2 are location 3 I will shift them to location 2. So I had 2 marbles. So basically add these 2 marbles at location 2, because location 2 already had 2 marbles, which was of 1. Again for 3 also it came in picture. So again just keep on adding those marbles at location 2. Again, as location 3 gone, so marbles at location 3 are gone. Ultimately what you saw was, okay, at location 1 marbles are 0, at location 3 marbles are 0, at location 2 marbles are actually 4. That's the reason. Ultimately in the last I'm concerned about the locations itself. Occupied locations. Occupied location is nothing but just one location, that is 2. So I will simply return just I have one location, that is 2 itself, with 4 marbles. But marbles I'm not concerned about. I'm just concerned about the location having at least 1 marble, and that's how you can solve it. Now while solving it, you understood what all is required. See, as we were about to say, okay, for every location I need to keep track the number of marbles at that. So I can simply use an unordered map or a hash map. Let's say it as MP. So for that MP, whatsoever location is there, and location is nothing but this. Okay, 1 is a location, 1 is a location, 3 is a location, 3 is a location. So at every location I will just keep track. Okay, what is the count? So as soon as any marble comes in, I will just keep on adding a 1 for that. So with this I will just say, okay, MP of 1 is actually a 2, MP of 3 is actually a 2. For location 1, count of marbles is 2, count of marbles is 2. For location 3, count of marbles is 2. Now as soon as I will go on add this list from 2, and we know that both of them have the same size. So as I will land on the 1, I will say, okay, hey bro, whatsoever number of marbles are at 1, please shift them to location 2. So whatsoever marbles were at 1, so whatsoever key was 1, please, whatsoever key, okay, for 1, I will just have to shift all the marbles at 2. So I will just say, okay, at location 2, whatsoever marbles were there existingly at location 2, whatsoever marbles were there initially at location 2, marbles initially were 0. Please shift all the marbles of 1 to 2. So I will just simply add a 2, because all the marbles at location 1, which were 2, are shifted to location 2 itself. And also please make it 0, because it is no more there. And then at location 3 I will land on. I will just simply go and shift all the marbles to location 2 itself again. Same again happen at location 3. I will just say, ask, hey bro, how many marbles you have? Okay, I have 2 marbles. No worries bro. Please can you just give all your marbles to location 2? Yeah bro, I will for sure give it. Cool. It will go to location 2 and it will become a 0. And that's how you will ultimately get a map plus something like this, which means map of 1 is 0, map of 3 is 2, sorry, map of 3 is 0, map of 2 is 4. Ultimately I'll go and finally iterate on my map and ask, hey bro, what are the locations having a non-zero marbles? So I will go and iterate and ask, hey bro, have you a non-zero marble? Bro, I have 0 marbles. Cool bro, no worries. I have also 0 marbles. Cool bro, no worries. Bro, I have 4 marbles, which means I have marbles, which means my location is actually occupied. So I'll just take this location as a key. And ultimately I will have all the keys in my answer, and I will simply sort that answer list. The only tricky part in this is, what if I ask you, hey bro, if I had a location 2 and I have to move to location 2 itself. So what you could have done was, okay, if you another step was, let's say location 2 to location 2. So MP of 2 was already there. So no shifting is actually required, because location 2 to location 2, shifting on the same location, it's not required. So either you handle that stuff in your code itself, or just ignore this case at all. If you are moving at the same location again, which means moving not at all itself. So either you can handle this or you can handle this in the code itself, or you can just skip this condition itself altogether. So it was the entire thing, and this was nothing extra. We just followed the exact same procedure given in the code, just a small data structure to actually store for the location how many number of marbles are required, because I need to change that location, which means 1 to 2, 3 to 2. For that I need to change the key itself. That's the reason I just use an unordered map. Let's quickly jump to the code itself. Before that, can we issue for 5 likes? Just 2 more likes. That would be super great. That was pretty easy. Firstly, I use an unordered map to firstly, it's an answer vector which will store the actually occupied locations, which means locations having at least some marbles. So for that, I use an unordered map to actually know, okay, for that location is a key and number of marbles at that location is a value. I simply iterated on my nums itself to know, okay, for every location, location is the key. What is the count of marbles I have? As in the first example itself, you saw for location 1, I have count of marbles as 2. For location 3, I have count of marbles as 3 itself. I hope my screen is visible. Yep. Now, I'll simply go on to all the, okay, from move from to move to. I'll simply go on to that, right? Simply going on to from move from to move to, which means that array itself, I have the start, okay, I have to move from this location, which is the start location, to the which location, which is the end location. I have to move on. I'll just simply use this condition, okay, if the start and end both are same, which means it's not required to move at all, simply skip it. So I just simply skip that. Else, if it is not same, which means if it is different, so you have to move ultimately to end. So basically at end, I'll bring everything from the start. From the start, I brought everything to the end, which means MP of end. And for sure, as I have brought everything to end itself, so please make your start as 0. Ultimately, I have moved every of those from move to move through. Now I will just keep on going in my entire map and see what all keys have a non-zero value, because it just means, okay, that location is actually having some marbles. So I'll just go and ask, hey bro, if you have some value, which means if you have some marbles, okay, your location is actually required. If it's required, simply I'll push back in my answer. And ultimately, I just simply sort that stuff down, sort this array down, and because ultimately I need to give the sorted list of occupied positions. I've got the occupied position in my answer, but I need to sort this down. So I'll just simply get this sorted and I'll simply get the answer sorted. That is all for this question. Let's quickly jump to the question number 3. It's pretty simple, but before that, can we 50 likes? 50 likes, that would be great. Quickly jump on to the chats itself, but yeah, before that, can we like just 4 more? That would be super great. Okay, Gautam Sajman, पता है, सो जाओ भाई, आराम करो. Legit, I did not sleep, so I slept legit half an hour. I took a nap before actually starting the stream because I was super sleepy. Third question was the most weird. It was not weird, it was actually standard. If you think third question was weird, so today we will see that it was a very standard question. It should be solvable for sure. It's a very standard and very easy recursive question. We will see how to think, what to think, and firstly, constraints help a lot to think in these kind of questions. Set makes it much easier. Cool. Let's quickly number question number 3. Again, a great hype for question number 3. So partition string into minimum beautiful substrings. Now, I have a binary string S, cool, a string S, but it's actually representing a binary number. Partition the string into one or more substrings. Okay, I have to partition the string into one or more substrings such that each substring is beautiful. And how we define beautiful? A beautiful string is defined as it does not contain leading 0, which means a substring should not start with 0 for sure. Okay, this is one condition. And its binary representation, which means, okay, I have this substring, its binary representation, converting this binary representation into a number. Okay, let's say it's just converted to a number x. It needs to be a power of 5, which means it needs to be power of 5, which means 5 square. Okay, 5 raised to power 1, 5 raised to power 0, 5 raised to power 3, and so on and so forth, which means it should be exactly, okay, every time if I do a modulo with 5, it should land into a 1. something like that, right? Which means it should be X number form, it should be a power of 5. It is the condition of being a beautiful sub-array, and I have to return the minimum number of substrings in such partition. Okay, I have this string, I have to do minimum number of partitions. Cool. Minimum number of partitions I have to do such that every substring is actually a beautiful substring. Now, if it is impossible to partition the string S, which means, let's say if it is something like 0 0 0 or maybe 0 1 0 1, because starting off with 0 itself, which means if anyway it is impossible to partition such a string into multiple substrings, then I will just say return a -1 in that case. Now, okay, it just say, okay, what's a substring like? Now, if we just simply go and say, okay, 1 0 1 1. Now, for sure, one thing, I will handle this condition. Primarily. It is one such condition. Okay, I cannot start. I will just try to build my partition. If you have solved today's problem, then in that I specifically told, okay, we have to make partitions, right? Now, if I have to make partitions, and I will initially it's just an intuition, it's a standard intuition that, okay, if you have to, and it's not required to actually think in that way, but yeah, just say, okay, we'll try to put this character in this partition or the next partition. Or maybe think of this as, if you are starting at this location, right, you will just try to make one substring, right? I am starting at 1 0 1 1. I will try to make it one substring like this, and then I will try to make it rest a substring like this. Or I could have done is, let's make it one substring like this and one remaining like this, which means when I say remaining, which means I will still again go and operate on the remaining part. So I'm just trying for all these starting substrings. Let's say I'll try for this substring and then I'll think for this. Let's say I tried for the entire substring and I will think for it nothing. So I am trying for everything down. And why is that case? Maybe I'm not sure. Maybe I can try it because the constraints are pretty small. So I can try everything down, which means I can try to make all such substring patterns. Ultimately, my aim is to break this, to basically partition this whole entire string into multiple substrings, which means for sure if I want to partition it, I have to start partitioning. So I will just, okay, make first string I just took as a first substring like this, and I'll think for the remaining part. When I say think for the remaining part, again the same stuff it's going to be applied. Think it as a one substring and think of this, or maybe think of this as one substring, then think of this, and so on and so forth. But it is just thinking and taking one substring at a time. So I am thinking what I can do is, maybe I can try off all these substrings, and then I will just think of the remaining part. Okay, again try for all the substrings, so it can go in this way. But shall we do it? Yeah, we can. By the constraints it look like, okay, it should be simple, short, but what we actually required to actually start. Now I know I am starting from the starting index. Now ultimately, to take the first substring itself, I need some ending index. Let's say I take the ending index. I know starting index is for sure 0. Let's take the ending index as I itself. So I know my first substring, it can be 1, or it can be a 1 0, which means I is here, or it can be a 1 0 1, or it can be a 1 0 1 1. Let's say it is a 1 0 1, which means I is here. So for the next, and it is, see, when we think of recursion, we just think in this way. Anyways, my recursion will bring me some answer. What I want is, and see why I thought of recursion is, I just want to try every possible substrings. Now how every possible substrings? I just knew, okay, I will start from 0 to try for every possible partition. I need to fix my first partition. Now to fix my first partition, I have multiple ways. When I say fix my first partition, I need to fix my first substring. To fix my first substring, I had multiple ways. Now, first, my main thought was, see, in a recursion, there are 3 steps. base condition, recursive condition, and the return. What you have to return, integer or what. So I just knew one thing. I just specifically went down on the part I have to get my first substring. To get the first substring, I have how many ways? I will simply go on, okay, whatever is the index, I have to start from, and I will try to go and put in every indexes, which means, let's say my starting index, let's say name it as start S. So I know, okay, it's my starting index. I have to go and try for all the substrings, right? So I just try to go for I here. Okay, one substring it can be. I will just try to go here from S to I, another substring it can be. I'll again try to go from S to I, another substring it can be. I'll try to go from S to I, another substring it can be. So as I was trying for every substring, I try for every substring. Now remaining part, again I will go and ask recursion, hey bro, can you bring out minimum partition? I just choose one partition, and for choosing that one partition, I had n options. Because if the length is n, I had n options. Now I will go and ask, hey bro recursion, can you bring out the minimum number of partitions required for the remaining part? Which means if I end it at I will ask my recursion, hey bro, can you bring out the remaining number of partitions, minimum number of partitions for the I plus 1, starting from I plus 1. So the start next time would be I plus 1. Again, I will go and keep on trying until the end for the next part. And so ultimately, now you know one thing. Your recursive condition will have something like for loop, where you will start from the starting index and will keep on going and trying up till I is less than n. You will start from the starting index and you will keep on going until I is less than n, I plus 1, I plus plus. You will try to make a substring out of from S to I. You will make a substring. Now, and you will just ask your recursion. Let's say the recursion name is function. You will ask your recursion, hey bro, you will try to make this part as a one particular substring. One partition has been done. So because of making this as a substring, one partition has been done. Then you will go and ask your recursion, hey bro, can you please bring me the minimum possible value for starting from I plus 1. Your next starting is I plus 1, and that's all which you want your recursion to go. See, it's just a rough code which we are writing, but thinking of what we require. So ultimately we know we want our recursion to return minimum number of partitions. So for sure, our recursive function, whatsoever name it is, it will return me int, which is the minimum number of partitions. It will have function. Now it will have nothing but my starting also. So I can name it as I or starting or anything I can name it as. Let's name it as starting. Now we know, okay, it is something like this. Now what is the base condition like? Before this, can we look at, okay, we just wrote a rough condition. It is, I will just take a substring from S to I. Then I will just know I have taken this substring S to I, but I will just go and check for this particular part. But this substring S to I, if taken, needs to be actually good, because it needs to be a good substring, right? Only then I can grab it. When I say good, I will convert this substring which I took into its binary form, which means into its actual number. So that's 101. I will convert that to a number, let's say 5, and then I will check if that number is actually something of this form. So I will keep on dividing that number by 5, and I will see it should land back to 1. And another number should not come. If it is actually a good number, only then I can do this partition like. So I will just go and ask, hey bro, I am doing one partition from S to I. So one partition is done. He will bring me the remaining number of minimum partitions if I start from I plus 1. So if it is possible to do a partition from S to I, whatsoever answer I have, an answer I will initialize with the maximum value, because I want something as minimum number of partitions required. So I will just simply get, okay, this answer, and I will simply update it by a minimum, because I just want minimum number of partitions required. It will be my answer. That is how we build our recursion. We build our recursion condition. Now comes the base condition. When we say base condition, when will it end? Simply by looking at the constraints, it does not start with leading zeros. So before even starting out my recursion, I know I have to start from this S. I know I have to start from this S. So before even starting out, now you know, okay, what's the recursive condition? Now you know you have to return a minimum. So now you know the return condition. Now you know the condition also. Okay, you have to start from somewhere as S. But if you start from an S, if you start from an S, that S, it should not be a 0. So I will simply say, okay, bro, hey, if your S, if the starting S, when I say S, it's not a string, it's actually the index. So you can grab it as I also. If the S of I, S is a string itself which you're passing, so that starting character, if it's a 0, then for sure you cannot make a valid kind of partition. So you have to return something, because ultimately you have to return something. If it's a 0, you have to return something, and something that is invalid, because for sure that 0 should not contribute in your answer. You know what you're taking? You are taking minimum, which is minimum of answer comma 1 plus function of your I plus 1, let's say. So it will land somewhere here. So you need to return something in this function, something in this, that it should become such absurd that it should not come in your answer. Your answer will come in because it is returning minimum. It should not impact your answer because it is an invalid thing. So return something which is not minimum, which means which is more than the value required. Now you can return anything. It can be 100, 1000, anything. How I know that? Because the maximum number of partitions of this entire substring of length 15, it can be 15 itself. So return anything more than 15. It can be even 20, it can be even 100, it can be even 1000. But not go int max, because int max plus 1 will actually overflow and become a minimum value. So please make sure, and it is question overflow. It is one question which we have seen in the Leetcode daily problems itself. Leetcode daily problems which comes in, we have gone through exact same kind of questions where the overflow was happening, where we were choosing and doing recursion itself in the DP itself. Cool. Now we know, okay, one condition is if it is a 0, I have to return something maximum. Maximum for me is 100. More than 100 is actually, more than 15 is actually good for me. So even 16, even 20, everything will work. And also, now I know one thing. If I have reached end, which is standard condition, if my I has reached the end, which is the length n, so for sure it's good, it's very good. If I has reached n, simply return a 0, because you have completed all your partitions, you have simply reached the end, so simply return a 0, because partitions all are done, no partition extra required, so simply return a 0. And that's how you know what to return, you know what conditions to write, you know what conditions to return, and then you know what conditions to write the base condition. By this you have, and see, we have not yet thought shall we memorize it or not. We have just written down the recursive condition. If this recursive condition exceeds our, okay, I can't take it, maybe it is not possible, then maybe we can think of DP itself. But up till now we are sure, okay, something of recursion we can write for this problem itself. Now comes the constraints part. It's 15. We know that every time it's just going in for, see, it's as simple as that. If you want to visualize in the complexity stuff, simply go and ask him, hey bro, if I had a 10110, something like this, then for sure it will start with this substring, then this, then this, and then this, and then this. So every time you could easily see that, okay, you are going on to every of those substring. Now even if you go to every substring, which means you initially start off with every substring, okay, you have the substring as 15. Now 15 is something you will go on to every substring. Now as you choose one substring, again the part will flow in for the remaining part of this, which is, again, you will go and ask, hey bro, what is the remaining part for you? He will say, hey bro, I will just choose it or I will not choose it. Simply, again, he will try to choose or try to not choose it, choose it, try to not choose it, choose it, try to not choose it, and it will just keep on going. Let me quickly see the factorial. 1, 2, 3. Yep. So it will just try to go it and not, which means for this 15 it will just try to go, and for the remaining part it will just try to say, hey bro, shall I take it in this or not? Firstly, it will just go and skip. For this part itself, it will just try to again form one, take it or not. Okay, take this too, then again try to go for this part. So it will be around 2 raised to the power of what all length is remaining, which is a 15 in the worst case. But see, it is 14, it will just keep on reducing. So it will just keep on saying, hey bro, shall I take it, shall I not, shall I take it, shall I not? But it should not be this case, because actually, like, I was earlier thinking of factorial part, which means taking this. Earlier I was thinking of the exponential part, which means take it or not take it. But realizing it is something as, okay, taking all these as initials, that is 1, that is 15 is a ways. After it is being taken in the 15 ways, the remaining part is, let's say 1 way is taken, now remaining 14 ways are there. 2 is taken, again 1 way is taken, again the remaining 13 is there. Then 1 way is taken, again remaining 12 is there. 1 way is taken, again remaining 11 is there. Now for taking this 14, again I have simply 13 plus 12 plus 11 plus 10 and so on and so forth. Again for this, it will just keep on saying 12, because see, if you take this one, as you saw, choosing it, see, just grabbing a higher picture, choosing 1 as this particular 1 way. Now choosing for the remaining part, the length is 14, cool. Now choosing this 1 0, again a 1 way. Now choosing for the remaining part, which is 13, again choosing the length as 3, 1 way. Choosing for the remaining part, which is 12, again the length as 4, which is 4, oh, okay, 1 way. And then choosing for the remaining part, which is the length is 11, and so on and so forth. It will just keep on going. It is 14 plus 13. For this 14 again, what will happen? It will be nothing but, see, earlier it was 15 as the entire length, so it will be nothing but 13 plus 12 plus 11 plus 10 and so on and so forth. This, it will just keep on going. This 13 will be 12 plus 11 plus 10 and so on and so forth. It will again keep on going as 11 plus 10 plus and so on and so forth, a 10 plus and so on and so forth, a 9 plus and so on and so forth. So with this, you can easily see, okay, it will again keep on going for this particular 10 plus 9 plus 8 and so on and so forth. So every number, if we just go on back to 5, let's say 3, or here it will, let's say 2, and here it is 1. So it is just one way. For this 2, it is nothing but 1 plus 1. Don't take it at all. Let's take it 2. For this 2, it is nothing but 2 plus 1. For this 2 plus 1, this 2 will have again 2 ways, which is 1 plus 1. Again, it will keep on adding the sum. Now comes the part of the sum. What should be the sum? It should be 13, which is 12 plus 11 plus 10, and it will again keep on going. So cool. I didn't realize that it's actually this. Like, while I was solving it, I thought it's actually exponential, but it's not. It's kind of fish multiplication of these numbers. So right now, the actual complexity we have to find. Let's see. It's interesting. So we'll just keep on going at these numbers. If I just step it down to one number, let's say it's 13 plus 12 plus 10, which actually is something. Now this is something which is, let's say, x. It will be x plus no, it is actually, let's say it is x, it is y, so it is x plus y, right? This is a 3, so the fourth one which would be there, so it would be nothing but a 3 plus 2 plus 1, which is nothing but x plus y plus x plus y, which is nothing but 2 into x plus y, right? Now again a 5 would be nothing but a 4 plus 3 plus 2 plus 1, right? Which is 4 is nothing but 2 into x plus y, 3 is nothing but x plus y, a 2 is nothing but x, and a y is 1 is nothing but a y. So it's nothing but 4 into x plus y. So we saw from 4 to 5 a 2 came in picture, a 2 factor came in picture. As from 5 to 6 another a 2 factor will come in picture. 2 again a 2 factor will come in picture, it will become a 8 into x plus y. From 6 to 7 again a 8 factor will come in, again a 2 factor will come in picture, it will become a 16 into x plus y. So as it will keep on going, x factor will a 2 factor will come in picture, and ultimately it will become something less than at least 2 ratio of 15 x plus y. So it is nothing but around 32,000. X plus y is nothing but 2 or something. So that will for sure work, and for sure it will repeat for 15 times, so into 15. So at max n into exponential, which is 2 ratio power n times it can go as in complexity. So with this we proved that okay, complexity, and this is nothing but a 32,000 into 15, and that would for sure come in under 1e7. So that is how our complexity, and 32,000 something hota hai, so that is something. So yeah, that is okay, that would work for a complexity. Although if you don't want to go such deep, see right now I actually proved it, like okay, something like this is happening, don't know how, but the intuition of mine spoke that okay, it is taking, not taking. So I just easily assumed that earlier that okay, it is 2 raised to the power 15, around this. I just assumed that part. Like I didn't prove it entirely, which I proved it right now, because as I was proving, I was saying okay, it might go in the factorial ways, but as I broke it down the entire problem, and while building up back by this mathematical ways, we just figured out okay, actually it is this way. But while solving it in the contest itself, it was just intuition for me. But yeah, if still you were just confused, okay, why shall I prove this complexity? Simple, nothing required, simply memorize it. So everything, which means simply by just doing a memorization, and you know your code simply had a I index itself, so simply by memorization itself it will just simply switch to O of n. N will remain same because you have to go at every starting substring, and for that this part was actually going on in the entire remaining part to see okay, what is the minimum thing required. So you can just simply memorize that and simply bring it down to again n, so it will be O of n square itself if you do a simple memorization. So if you are concerned okay, why it is not required, why it should do, so you can simply do a memorization in DP to get your answer. But yeah, we actually saw okay, how this recursion is working, and this recursion how the complexity is being built, and so on and so forth. Cool. Yeah, time complexity is complex than the problem. That is correct. But yeah, see, it's mostly, see, as you start solving the problems itself now, you never know that how the intuition comes in picture. Like legit, I did not prove this entire stuff. I just by myself, by somehow I just got to know. And by the way, I was explaining, I figured out okay, what I thought was it was just an intuition of okay, it can be something like this, and just I wrote it without memorization at all. So yeah, that was something which is kind of, it should be proved afterwards. But yeah, intuition is actually way much better than most of stuff. But cool, let's quickly but if the folks liked it, can we please smash that like baby to actually 7 likes, just one more like, that would be super great. So basically other people have just gone, see, in this you can just solve it something like okay, you can, you know that 5 raised to power something is the number, so either you can actually make this numbers out, strings out, but I have gone the standard basic way which can be applied in any ways. So I have converted the string to a number and actually just verifying okay, that number is a power of 5 or not. So everything, like nothing is hard coded, everything is actually in the code itself. So let's quickly just see the code. Firstly, my recursive function, which will simply give me, as I will start from the index 0, because I know I have to start from the index. See, I know in the code itself I showed you I have to give the starting index itself, okay, from which index I am about to start. Before that, can we reach to 7 lakhs, that would be simple. Great. That would be great. One more, just cool. So I just showed you that it's a starting index which we can have. Now in the starting index itself, we will just go and see as the base condition. I told you, if it's a 0, for sure you need to return some high value which is more than 15. So you can return anything, 100,000, but don't return int max, because this one will get added in int max. So it should be something which is not int max, less than this. So, and I will simply go and ask him, hey bro, if the length is reached, simply return a 0, because I have done the good partitions for me. Then simply a int max, simply answer, getting it, okay. Simply answer is int max, or you can take it as any value which is high, 110, 120 or anything, it will still work. Then I go on from the starting index I go on to every of those until the end. I just try for every substring. So when I say substring, I mean from I to actually a j. I try for every substring from I to j, and I'm asking, hey bro, is this okay? And when I say okay, I will just go and ask for that substring from I to j. I'll convert that substring to a number and we'll check, okay, if that number is a power of 5. So is okay, we'll go and make a number out of the substring from I to j. It will just go and make a substring, make a number out of that substring from I to j by that value. It will just go and check, okay, if that is a power of 5 by simply doing a modulo with 5 every time, and ultimately it should be a 1. If it is at any step not modulo by 5 possible, then simply return a 0, because it's not a power of 5, else simply return a 1. By this is okay function, I just got to know if that particular substring, converting that to a number, if that is a power of 5. Now I have that particular is okay, is saying okay, it's a power of 5. If it is, you can simply go on forward. Now you will simply say, okay, one partition is done, I have got one substring, one partition is done. Simply go and return me the minimum number of partitions required for the remaining part, starting from j plus 1, because I took from I to j. So starting off from j plus 1 to end, you just go and bring me the value. So I'll just simply get the answer as the minimum value. I'm simply getting the answer. Cool. That is how, if this answer is actually more than 15, which is if it is more than 15, I just took it as to have in the, like, just have quickly coded, took as a 20. If it is more than 15, simply return a -1, because it's not possible to partition that. If it is not, simply return that value itself and you will be good to go. That was all for this question. That is how 0-1 knapsack would work. See, 0-1 knapsack we think of when we think take it or not take it. It is more of you have to go to every point. You can think of it. A parallel mind of a person, me also, thought of it as a 0-1 knapsack. That is the reason it's very easy. If we go back, okay, I know the complexity is around 2 to the power 15. I know it is 2, which means take it or not take it. 2 to the power 15. Every location I can have it like this. Or I can think of it as I have something like this, which means some locations, indexes. But thinking of 0-1 knapsack, you will take it or not take it. You will take it or not take it. Take it or not take it. Just give me any reasoning that how you thought of, okay, take it or not take it. How will you make the groups out of it? Groups out of it. That is something. Okay, let's say making one group is possible. Cool. Then for the other part of the group, how we will prove that something like this, take it, not take it, will happen for this other part of the group. Okay, for this, I will take 15 as the base for taking the first substring. For the remaining substring, that is, okay, after having the complexity around this, at around 2 to the power 15, it is easy to think of as knapsack. But initially as a knapsack, it's hard to go in the knapsack way, because it's actually, I don't think it's actually in the knapsack format, because knapsack, you can think of it as a knapsack way, but knapsack entirely is not intuitional for this, for sure. So thinking of it is in the backtracking way, maybe okay, the complexity is something like this, then maybe it's an abstract. It can work, but starting off, take it, not take it, something like this, it's not gonna happen, because we are making the groups and taking the substrings. Then for the again remaining part, we are taking the substrings. For this, we will have to take, and have to taking that all part. So that's the reason it is not a knapsack, which I consider, else maybe I'm wrong, but yeah, it's not a knapsack which we can consider. Complexity wise, we proved it something like this, but back everything which is 2 power is not necessarily important to a knapsack. Maybe, yeah, cool. That was for the third question. It was tricky one. Fourth one is pretty straight, like I don't think it's a Pride month, so I should not say about, oh, it's done, right? Pride month is done, I guess, not sure, but yeah, straight words and straight sentences. But yeah, cool. Before that, if the folks have liked it, can we please smash that like baby to 75 likes? That would be great. Just one more like. Cool, that is done. Thank you. Let's quickly jump on to question number 4. It's pretty easy. The constraints spoke a lot for this problem. Cool. Number of black blocks. Not being racist. Cool. But yeah, it is actually black and white. It is being. You are giving 2 integers m and n representing the dimensions of a indexed grid. Okay, I have a grid, m cross n grid. I am also given a 0 index 2D integer matrix called as coordinates. If you look at the constraints itself, m and n is not useful at all. I mean, like, not in that useful, which means if you have an m and n, you can't make a grid of size m cross n. So that is just for visual purposes, m cross n. You can't actually make a grid of size m cross n, because it will become 1e10, which is not possible in space or time terms. So it is one thing, make sure. Coordinates, okay, it's actually useful. Coordinates are useful, coordinates I can use it, else other things are just numbers, so that's not required. But yeah, the main part was I can use only coordinates. I can't use my grid. I can't make a grid. So please remember this part. And that is why, look at the constraint itself, we saw we can't make a grid. Now we have a 0 index 2D integer matrix called as coordinates, where the coordinates is nothing but x comma y. Simple. Indicates that the cell with the coordinates x comma y is colored black. Just saying, if any cell is in this coordinates, it is colored black. All the cells in the grid do not appear in the coordinates as are white. So basically, if any cell is in the coordinates, it is colored as black. If any cell is not, it is colored as white. Cool. A block, I just speak, the block, they define it as a 2x2 kind of grid, a 2x2 kind of a submatrix. It is a block. Now it will be having this cell, this cell, this cell, and this cell, right? Now it just says, okay, return a 0 index integer array ARR of size 5 such that ARR of I is the number of blocks that contains exactly I black cells. Now array of size 5, which means size 5 array, I equal to 0, I equal to 1, I equal to 2, I equal to 3, and I equal to 4. It is the array I have to return. When I say array, I mean for this particular I, it will just say me, hey bro, number of blocks having 0 as black cells, 0 black cells. If you see this block, it is having 0 black cells. That is why it is just saying, okay, if I just ask 4, it will just say me number of blocks having 4 black cells, which will be, if it is black, it is black, it is black, then this block is actually it will be counted in this. So I have, and for sure it can be only these ways, because a block, it can have none of these cells as black, either 1 as black, or 2 as black, or 3 as black, or maybe 4 as black, and I have to do it for the entire grid of m cross n, right? M cross n, and whatsoever cells are there, simply get them. Now looking at the example itself, what we know, one thing Firstly, we look at the example itself. What the example is saying. Let's skip the ad, skip the ad, skip the ad. Please don't play the ad, please. Yeah, thank you. I don't know why it started picking that. Oh yeah. So firstly, the example itself, it's an M cross N matrix. Only one coordinate is colored. It's a 0, 0. So for sure, we will just see, okay, if I just ask, hey bro, for this block, it will just say me, I have one colored cell. So one colored cell. For this block, no colored cell. Okay, no colored cell. For this block, no colored cell. Cool, no colored cell. For this block, no colored cell. Cool, no colored cell. So it is my ultimately answer 31000. 31000, 31000 is my answer. Look at the next example. This is again a M cross N matrix. Again, same. I will take for I equal to 0, I equal to 1, I equal to 2, I equal to 3, I equal to 4. 1, 2, 3, 4. Sorry, 0, 1, 2, 3, 4. 0, 1, 2, 3, and 4. Cool. Now we will actually go and look at, hey bro, 0, 0. I will just go and say, hey bro, for you bro, 2 are colored. Okay, 2 are colored. Hey bro, for you, hey bro, for me also 2 are colored. Cool bro, no worries. Hey bro, for you, hey bro, for me one is colored. Cool bro, no worries. Hey bro, for you, bro, for me also 1 is colored. Cool bro, no worries. So the answer is 0, 2, 2, 0, 0. Now we look at the example itself. We look, okay, what's happening, all that stuff. The main part is I cannot use the entire, I cannot iterate. As I was showing, I was going on every row and then making a block. I was going on every row, making a block, and then asking, hey bro, what all number of colored black cells you have, and then placing it in my array. I can't do it because I cannot make a size, or I cannot iterate on my M cross N matrix. I cannot make this matrix, I cannot iterate on this matrix altogether. So one thing is I cannot do it. One thing but I know is my coordinates is pretty less. So one thing is for sure, I can iterate on all my coordinates. I can iterate on all my coordinates. So is there anything I can figure out, which means, okay, if I am at this coordinate, so what I am trying to do is, for every coordinate, I will try to bring in the contribution of number of black cells in my answer. So what I will do is, for this first coordinate, I will just go and ask him, hey bro, what is your contribution in whatsoever blocks? In whatsoever blocks, and for sure it can be at max 4 blocks, because if this is one cell, its contribution, it can be either in this cell, or in this cell, or in this cell, or in this block, or in this block. So one cell can have contribution at max 4 blocks. It can have contribution and at max 4 blocks if it is having a contribution, right? So I will just go and ask, hey bro, what is your contribution? What is the number of black cells in your block? I will go and ask him, hey bro, for this, because see, I know I can only go on coordinates. For every coordinate, I will go and ask, bro, you should give me some answer. You should bring me some value. Now you can bring me some value only when I can grab some contribution from you, what you are contributing. So he will just go and ask him, bro, I am a 0, 0. What do you want from me? I want, bro, what is your contribution? Whatsoever block you are in, and you can be in 3 blocks. You can be in 4 blocks. One block is something like this. One block is something like this. One block is something like this. And one block is something like this. You will easily see that, okay, this is a wrong block, this is a wrong block, this is a wrong block, which means the left, all these blocks are actually out of this. So only valid block is inside. Now I will ask him, hey bro, okay, you just got to know this is one valid block for you, but bro, what are you contributing? He will say, bro, I am contributing, okay, it is a block for me, and I can also see that, okay, it is not in my coordinates. When I say it is, which means 0, 1 is not in my coordinates. Ooh, yeah, it is not. 1, 0 is not in my coordinates. Ooh, it is not. But 1, 1 is in my coordinates. Okay, cool. So basically, bro, 0, 0, whatsoever block this 0, 0 is forming, it will have a contribution of 2. So I will just go and ask, hey bro, I know that 0, 0 has a block which has a contribution of 2 black cells. So please put a 1 for him. Cool, bro. I have put it. Now I will go on to next of my coordinate. I cannot go my next cell. I'll go on my next coordinate. I'll simply go and ask him, hey bro, how many blocks you can contribute to? He will say, bro, I can contribute to 4 blocks, because everyone can contribute in 4 blocks. One block is this. Where is my pink cell? Yep. One block is this. One block is this. One block is this. And one block is this. So I'll just go and start with this block, because this cell 1, 1 can now contribute in 4 blocks. Now I will again go and ask, hey bro, for this 1, 1, as it is in the bottom right cell, it is the head cell, I'll go for this block. Hey bro, what is your contribution like? He will say, bro, for this cell I can see, okay, it is not in the coordinates, it is not in the coordinates, but it is in the coordinates. So for this particular block, I can say, bro, the contribution is actually, number of black cells is actually a 2. So for short, number of black cells is 2. I can simply say it is having a contribution as 2. So basically I will just simply add it. I simply added another particular block. Okay, I got one more block, but you saw one thing. Wasn't it repeating? This was impacting this, and again this is impacting this. Yeah. Hold your horses. I know you cannot hold it, but yeah, hold your horses. We will come back again. But yeah, we know we were repeating stuff. And for sure, for this it was being counted. Then again for this it is being counted. We know we are repeating stuff. But yeah, let's hold it. Simply going on to the next block for simple this 1, 1. Next block for this 1, 1. Cool. Bro. It is not in my coordinates. It's not in my coordinates, bro. It is in my coordinates, which means 0, 2 is in my coordinates. Yeah, it is in my coordinates. I can simply see. I can find. I can look at it. Yeah, it is. So for sure, bro, this block for 1, 1, for me 1, 1, the block which I can provide you, I know for 1, for every cell I can give you 4 blocks. So one block I have done. Another block for me 1, 1 itself, I know its contribution is also having 2 black cells. So for sure, I'll simply go and add another block for this 2 black cells. For 2 black cells, another block is found. Cool. Now simply going on to next particular block for this 1, 1. 1, 1, next block. I'll again go and search, bro. Hey bro, are you there? Hey bro, are you there? Hey bro, are you there? No one is there. Cool. For this, number of black cells is 1. Only he is there. So contribution of this is nothing but 1. Again, it will go and ask, hey bro, for this, he is not there. Simply, cool bro. I'll simply have just 1 black cells. So contribution it's nothing but 2. Now again, okay, next particular, I land on to cell 0, 2. Simply it will go and find all the blocks it can have. Again, it can have this 1 block, it can have this 1 block, it can have this 1 block, it can have this 1 block. All the remaining right blocks are invalid. Only one block is valid itself. So I'll go and ask, hey bro, for 0, 2 as the parent cell, he's not there, and 1, 1 is there. Cool, no worries bro, but number of black cells found are 2. So for sure, you will go in and contribute in the 2 itself. So I'll contribute it as 2. But again, you saw it is being repeated. For 1, 1, you counted that earlier also, and it's being repeated. That is how you will see something that is ultimately being made by evaluating these coordinates. But as we have 2 black cells, and it's easily shown, as we had 2 black cells, each black cells was contributing 1 cell. So for sure, I need to divide it by 2 to get actual number of unique black cells, because every block was being, see, every block was having 2 black cells, right? So it was contributing 1 block, so for sure ultimately it will give me 1 plus 1, which is 2, but actually it was just 1 block. So divide by 2. If it would have been a 3 black cells, let's say it would have been 3 black cells, so it would contribute 1 block, which is actually a 1 plus 1 plus 1, which is actually a 3, but actually it's just a 1 block. Simply divide by 3. So simply, if we had number of black cells, if it is 2, so for sure everyone would have contributed 1 block for them. So simply divide by number of black cells, which is nothing but 2 itself, which is the index itself, to get the actual unique number of blocks. So okay, it is the two blocks I can find. It is two blocks I can find. Ultimately, I can find two blocks 0, 0, 0. That is how you can simply, by trading on the coordinates itself, you can simply get the answer itself. Cool. Let's quickly jump on to the code itself. But yeah, if the folks have liked it, can we please smash the like button to 85 likes? That would be super great. But yeah, you know, right, how you thought of it. You know, n cross m would not work. Only thing which you have with you is coordinates. With coordinate, you have to bring the contribution of every answer. You have to bring the contribution, and by thinking of the contribution, you just go on to every coordinates and you think, okay, hey bro, what value you can provide in my answer. If you can, just please add my answer. When we were adding, we saw something is being counted twice or multiple times, but we know, okay, at the back of our head, we know something is being counted twice, so it's not right. We need to correct in the end. We will modify in the end. We modified that in the end itself by just saying, okay, everything, if it's a block having 3 back cells, every cell will contribute 1 block again and again, so simply divide that by 3. Cool. Let's quickly jump on the code itself. But yeah, before that, can we quickly reach to 85 likes? That would be super great. What happened to my voice? Nothing. See, it's actually a very clean code. So that was one great thing. Simply, firstly, as we saw that I need one thing for sure. I need to, at every point for this block itself, when he was the parent, then he will go and check for this cell, if it is in the coordinates. So please make a map of coordinates so that you don't have to iterate on the coordinates every time. So I will just take a map having a pair to actually say, okay, hey bro, 0, 0 is in the coordinates, 1, 1 is in the coordinates, 0, 2 is in the coordinates itself. So I'll simply take a map, and with this map, I will just simply get to know for any cell, for any coordinates x, y, if that is in the actual coordinates array or not, by simply taking a map. So I will just simply take a map itself, or you can take a set also. Anyways, anything will work, because everything is unique. All the things are unique. All the coordinates are unique. So you can take a set or a map, anything you can take, simply placing your x, y coordinates in the set or the map. Now, when it is done, you have to actually start off with your answer, and you build your answer. You just went on to every of those coordinates which you have in your set, or you can easily go in this vector also. That is no worries at all. Now, as I told you, every cell will have 4 blocks it can contribute to. So as this cell, as a parent cell, so basically it is acting as a top left cell. So if it is a top left cell, which means I'll show in the picture also. So one way is, if I am, okay, as I showed you here also, for this cell right here, either it can be acting as the bottom right cell, right? It is 1, 1, right? 1, 1 is my parent cell. For this parent cell as a block, it can be acting as a bottom right cell. It can be acting as a bottom left cell. It can be acting as a top right cell. It can be acting as a top left cell. So there are 4 possibilities for every block to be there. So simply, as the top left cell, as the top right cell, as the bottom left cell, and as the bottom right cell, it is a 4 possibilities, and everything is same. So let's look at the one possibility, which means if it is at the top left cell. Now, as we showed, okay, sorry, I didn't show the code. So yeah, it can have 4 possibilities, as the top left cell, as the top right cell, as the bottom left cell, and as the bottom right cell. Right now, if we look back again, if it is at the top left cell, let's say, which means if this x, y is the top left cell, so for sure I know see, I just want to know the remaining coordinates. It will be x, y plus 1. It will be x plus 1, y. It will be x plus 1, y plus 1. And similarly, if we know any of the, okay, if for the, let's say, if it is a top right cell, so I can get to know all these 3 coordinates. If I know if it is a bottom left cell, I can know all these 3 coordinates. If I know it is a bottom right cell, I can know all these 3 coordinates. So basically, if I know this x, y, I can know all the 3 coordinates, because it is simply plus 1, minus 1, something like this, right? Quickly jump on the code. So if it is a top left cell, I know it is a x plus 1, y, 1 cell to the down. It is x comma y plus 1, one cell to the right. It is x plus 1 comma y plus 1, one cell to the diagonal. Now I know is okay, will check, hey bro, are you in the bounds of my matrix or not? So basically we also saw that if it is as one of the cells, so it can have these 4 possibilities, right? But we know that the possibility like this is out of bounds of the matrix. These cells does not exist, this cells does not exist. So we need to check, okay, if it is in the bounds of the matrix or not. By this we can simply go and say, hey bro, are you okay, are you in the bounds of the matrix? If it is, then it will simply return a true. So every of this okay will simply say me, hey bro, I am in the bound of my matrix. If it is in the case, then simply one black cell is x comma y itself. X comma y is black cell itself for sure, because in the coordinates you only had the black cells and your this is having only the black cells itself. So you know one thing, is my screen visible? Yeah. So you know one thing, your result is for sure 1. Now what can add? If your x plus 1 comma y is also black cell, so I'll simply go and ask, hey bro, in my set, please bro, just find me if that x comma y is possible. So let's have a function called as f. It will go and just say, is that x comma y, is it in your f, which is the set which we made earlier, to know if that coordinate is actually in your set or not. So you just simply go and grab that x plus 1 comma y and asking him, hey bro, are you in the set? If it is, it will simply return a true, or it will return a false if it is not. If it is returning a true, which means it is there, simply adding a 1 for a simple black cell. So if it is a 1, simply add a 1, simply by just simply contributing for this particular head, which is x comma y, as a top left cell, what all cells are black. Simply getting, okay, if it is a black, simply add a plus 1 to know for this block number of black cells are these many. So for this block, which is x comma y, x plus 1 comma y, x comma y plus 1, x plus 1 comma y plus 1, it's a block which we have made as a parent cell x comma y. It is having result number of black cells. So simply in your answer which you have made, you know black cells number is the result, so simply add a plus 1 because you have found one block, and simply you keep on repeating the process by keeping this cell as a top right, as the bottom left, and as a bottom right. Now when this is done, when this is entirely done, which means for every coordinate you have just made your answer in your answer, but you know one thing, your answer was repeated. You know your answer was repeated, so you just quickly go on to all the cells and will simply say, hey bro, please do a answer is equals to answer divided by I. By this you will just get to know, hey bro, what all actual number of blocks are for each corresponding black cell, which means for this black cells as 1, what are the number of blocks it actually has. For the black cell as 2, what are the number of blocks it has had. So I simply go on from 1 to n. You saw we did not find the answer for number of black cells as a 0, which means all are empty. We could not, because our answer, our result is starting itself from the 1 itself. So for 0, our value is never found, and simply it's actually also true. So for number of black cells as 0, we have to find the answers also. So what we will do is simply going the reverse psychological way. How? We know that in total the number of cells it can be, we know that, okay, it can be this particular it can be this, it can be this, it can be this, and it can be this, which means it is ultimately going up till this end and up till this end. So for sure, if it is a m, it is a n, or maybe let's say if it is a m, it is a n. I will go up till, see, when I say m, I mean the entire n. So I will go up till n minus 1. I'll go up till m minus 1. So I know number of cells, number of blocks ultimately possible are n minus 1 into m minus 1. It is the number of blocks which are possible. For this you saw it was 3 minus 1, which is 2 into 2. It is maximum number of blocks possible are 4. I just found it answer, okay, 1 0 0 0. It is the answer which I have found it. I have not found the answer for I equal to 0, which means the black cells as 0. But I know in total the number of blocks are 4. Ultimately for this colored black cells, I have found in total it is 1. So for sure the remaining are actually in this particular 0 as a block, as the blocks. So ultimately I'll just get, okay, 3 as the number of blocks for this colored cell as 0. Colored cell, black cell as 0. And that's how you will simply go and find the answer for this 1 to 4, add it, and then you know simply the total number of blocks possible, which is actually n minus 1 into n minus 1, and you know n and m both are 1e5, so 1e5 into 1e5, which is 1e10. So please make sure 1e10 is more than the integer bounds, so please do a long multiplication. So it is a, so please, if you multiply it, convert that to a long and then multiply, so as to get this number as a long number and not the actual integer number. So by this I will just get all the number of blocks possible. I will simply go and add number of blocks by these colored cells and simply subtract it from the total number of blocks possible to get the blocks possible for my 0 black cells. Simply going that way only, getting that to total also, because I know that my answer of 0 is actually a m minus 1 into m minus 1. 1 LL is just converting that to a long, and also subtracting the total from the answer of 0, because I know my total is actually from 1 to n, what is the number of blocks I had taken. So remaining blocks are actually for the 0 black cells, and that's how you can simply build your answer array, and that's how you can simply get it done. Cool. I hope that you guys liked it. If yes, then can we quickly smash that like baby to 85 likes? That would be super great. That would be super great. Can you review my CV? We are just about to reach 25k, so we have made it a 25k special CV review. If you don't know, I was just starting off with that CV review itself, but can we please, it's just a humble request, if you guys can share that. I saw a folk writing down, if we just do a live stream, he will share. So quick shout out to that folk. We did a live stream, so can we actually reach to 85 likes? Sorry, 25. So yeah, before that, can we reach to 85 likes? Just 2 more likes, that would be super great. And can we reach to 25k subs? Our resume review video will be coming at 25k special. That's fine. So let's quickly, if possible, can we reach to 25k? That would be super great. But yeah, Aryan bro, can you increase video upload frequency because placements are too close, or else bring something placement prep? How many did you go to Cafe 96? Cafe 96. I have heard of this. Not sure where I've heard of it. Cool. Anyone have any doubts? They can write it down below. That is all for today. That was actually not hard problems, but actually interesting ones, especially third and fourth. Not hard. Third one was easy, but tricky for complexity wise. Fourth one was easy. I will say easier than the third one. In terms of how you think of it, it's actually very intuitive to actually think of in the coordinates way, because constraints are pretty big for N and M. भाई MNIT में है वो. अच्छा हाँ, got it. अच्छा हाँ, मैं वही सोचूं. I have heard of that. Cafe 96. I also went. I have also gone into that Cafe 96. That's nice though. Cool. Any questions, any doubts? Aryan bro, can you increase the video? Yeah, I try. You don't know how that is done. Bhaiya, can we prevent the multi-counting instead of doing by 2, by 3, by 4? Yeah, that's what we did, right? We are preventing multi-counting by doing a by 2, by 3, by 4 itself. Cool. Bhaiya, oh, you guys are writing the same stuff again and again. cool tech up भाई बहुत ज़्यादा बार लिख दिया है Aryan bro can you increase your frequency see bro I try my best to have the best frequency इसमें फट जाती है यार मेरी तो रिस्पेक्ट प्लस स्किपिंग एड थैंक यू कंस्ट्रेंट से पता चला कि फोकस ब्लैक बॉक्स पे करना है नहीं ना कि व्हाइट बॉक्स पे दैट इज करेक्ट माय अप्रोच इज प्रॉपर टू रीच पावर एन आई एक्सप्लेन द अप्रोच अबव आशुतोष cool yep that is actually great yeah you can actually build this formula right up that's actually correct time complexity is complex in the problem cool to af simple approach if problem gives then apply db among these cool approach is proper to its power n thing I correct works to enable cool so it's weird super easy time cool anything anyone else to write can please write down that would be super great are you still doing cp I don't even get time to eat food I can't do cp like I try but you know everything is so matlab legit as soon as you know multiple things going on just occupied with that but cool I have a Utkarsh Jain I have a 7 CGPA no intern 2024 batch electrical branch Leetcode 2000 plus rating specialist at CF don't what to do make projects if you don't have you should have projects because your rating is nice you're doing good in CP just be thoda or good code and accept computer networks is not that required or for sure but yeah make good projects 7 CGPA है कोई बात नहीं है but yeah make good projects that would be good and also try to increase your rating a bit more be more consistent and do more hard problems you should not do more of easy problems now because do more of hard problems or considering on क्या कहते हैं code forces you can do 1700 to 1800 problems that would be great to actually increase from specialist to expert code done except how manage your time bro वही भाई होता नहीं है मुझसे manage time project is ready it should be a good one when I say ready it should not be a clone how you manage your time bro tech up make one video on that time management that would actually can come in yeah for sure tech up Utkarsh Jain that is done भैया I want not to count the previous counted blocks I don't want to divide अच्छा see that can also work but then you have to keep track of the pair which means for a block you have to keep track okay you counted the previous like in this you have to consider one pattern the top left cell the top left which means let's say the cell is like this right let's say A B C D so you have to keep a track let's take a map or something like that like keep a track A B C D pair has occurred before so please don't count that pair again so either go via that way that while checking that for every particular cell a block you just know okay for this block for this particular apparent cell which is a black cell I know it is a block right here I know A B C D is the order which I know I have made a map to know if that particular block has occurred before or not that has occurred before don't count it again so you have to take up kind of again a map to keep track of that which can be a bit tiring or maybe you can have another way at the top of my mind I can think of this way to actually figure out it should not repeat again but yeah you were gold medalist why you don't opted for MS भाई मुझसे पढ़ाई नहीं होती मुझे ये समझ नहीं आता how come people see I just showed you in the video bringing grades is nothing to do with how good you study is to know that what to study तुम्हें college is not JEE and in that video how I got 4 gold medals if you have not watched it you can just go and watch see whenever you want to watch any of the videos which are bakwas kind of which is not actually related to coding part not doing the actual coding part just go and watch the playlist called as special videos in our YouTube channel. In that I put in every videos like that which is not coding related, which is kind of a high level guidance part. So that is in the special videos playlist. So in that you can just go and look for let's skip the ads. Skip. Yeah. Let's go and see in that how to bring the grades. It's nothing to do with how good, how long you study. It's all about what you study. So you have to just study that part which is important, and that will come in exam, and that is fixed. एग्जाम में क्या आना है सबको पता होता है, सबको नहीं पता होता, बट हाँ जिसको पता होता है उसी नंबर आते हैं. This is about you study. But yeah, if the folks are still watching, can we reach 90 likes? 90 likes, that would be super great. And yeah, if you have not subscribed or not asked any of your friends to subscribe, can we please, because we have done our 25k special. We will be doing a 25k special resume review, in which we will be reviewing your resume which you have posted in our Telegram channel. For sure, I have reviewed 3 resumes so far, and I have found so many great points. Although on high level it looks very good, but there needs to have some tweaks to actually make it much better. So yeah, that would be great. But yeah, we will be ending the stream in 3-4 minutes. So cool. Do standard companies ask questions related to DSU in interview, or we can skip those topics? Companies ask. When you say standard companies, I will consider companies as at least Flipkart, Amazon, these companies also, and they ask DSUs, because DSU is pretty easier. Implementing DSU code itself is actually very short, and then implementation of DSU is itself very standard. So DSU, it can be asked. I got stuck in the question 4 because I thought not of division but preventing counting them again. Yeah, you can do it, but for that you have to think of using a map, because this block should not repeat again then. And this block, it can repeat in 4 ways if it is a top left, top right, bottom left, bottom right. So for that you have to take a map. I'm going to make a LinkedIn post for you. 25k. I feel your channel is underrated. Your content is super helpful for me. Thank you so much. Tech up. Yeah, वैसे I also want to post on LinkedIn, but मतलब वही है कि you have to write a post, you have to write something meaningful. तो वही है कि I just try to, but हो नहीं पाता. But yeah, thank you so much for this contribution by you guys. That's so meaningful. Question, I think I don't have the time to go from specialist to expert because placements are near and it will take at least 4 months. It would not. See, when we say placements, 4 placements are near. See, you can see it will either decrease or increase, no worries. But yeah, maybe you can start parallelly. See, if you are just scared of reducing your rating on this prime account, then you can make your XYZ alternate account and then maybe try to increase in that, because solving problem and rating are 2 different things. If you will solve it, you will get better at problem solving. So please don't stop giving contest. Maybe if you just are scared, you want to show that rating in the actual resume, so have that account. Don't give contest on that account, but make an alternate account. But please be punctual on that, and please give. See, when we make an alternate account now, so actually the mind of solving it as a main account, it goes. So it's the reason I don't recommend making an alternate account for solving problems. But if we are scared, the placements are coming soon. So, but still, solve problems is very, because see, it's just a perception of us that okay, it can't be done. It can be done. It's just that how punctually we are doing it. But yeah, it just looks good in speaking, but it's actually hard. But still, it is actually possible. Hard, but possible. So yeah, you can just do it in that way also. Question 3, question ka also in the build. Yep, Ashutosh, that is correct. I got MLE. I use a matrix. Yeah, for sure. MLE and TLE both will come if you will make the matrix. So for sure, matrix cannot be made in this problem. भाई आपकी intern कौन सी कंपनी में लगी थी? Goldman Sachs में ही लगी थी भाई. Thank you so much for these efforts. These sessions are really booster after contest. Again, thanks a lot. Thanks so much, Rahul. I hope that you guys liked it. Let's end this stream right here. Thank you so much for coming in, joining in. Thank you so much for watching. That is so well of you guys. See you. Bye bye. 25K special. Please. बहुत कम है यार, बस 400 500 600 के आसपास ही करने हैं. That would be great. And for sure, if you have not watched the resume building video, you can just go and watch it. And also the shorts आज का देखा हो तो अगर me solving problems. Very cool. Bye bye. See ya. Goodbye. Thank you. Tada. Goodbye. Thank you. Bye.